NTJ says, I have a topic for the Boaters Podcast if possible. I have a 2011 Mercury 40 horsepower four-stroke. It's making oil. I tested the thermostat and the fuel pump, and those seem to be okay. Everyone keeps telling me it's from idling too much. I do idle some, but I would like to idle around and use my fish finder. Are these engines not made to idle? Thank you for your time. And then also Basic Info Edit says, what about the Yamaha 200 show? Many owners can't get them to stop making oil, which is, this show is the SHO, super high output. Let's talk about the first one first and then move on to the show after, because these are probably two different topics. There's a few different things that I would say are going to be a variable here. So for one, let's clarify what making oil is. And to me, when you say an engine is making oil, that says to me that you do an oil change on the engine, and then at 100 hours later, let's say you put in 6.5 quarts or 6 quarts, a gallon and a half of oil, 6 quarts of oil. You put in 6 quarts of oil for the oil change, and then whenever you run 100 hours and do the second oil change, you now have 3 gallons of oil. So you've made a gallon and a half of oil, or 6 more quarts of oil. So that's what I would be considering making oil. Now, with that being said, there is another problem. On certain models, you have a fuel pump that is ran by the vacuum of the crankcase to pump fuel. So the vacuum in the crankcase creates a pulse, and there is a diaphragm-driven fuel pump that will mechanically pump fuel from your tank to the VST or the engine, whatever the model is. Some of them will vary. Now, that diaphragm inside that fuel pump, if it ruptures or gets a crack in it or it breaks or whatever, it will then just be putting fuel straight into the crankcase, which is going to fill the crankcase full of oil, and the engine's not going to run because the crankcase is going to be too full of fuel and oil that the crank can't spin around, and it's going to be pouring out the dipstick and all kinds of other problems. It's going to be pushing past the rings, going to flood the cylinder walls. The engine's not going to run. That's a separate issue from making oil, an issue nonetheless, but it is something that some people might say that that's making oil. I wouldn't consider that making oil, because you're not really making oil. You're just dumping fuel into the crankcase to where the engine won't even run. And then on other models like a Mercury Verado, early models, the L6 had a fuel supply module with a fuel pressure regulator inside the fuel supply module, and that is ran off of intake manifold. So your intake manifold, same thing, it creates a pulse based on pressure, vacuum, whatever, and it vacuum. And what that does is then there's a little hose in there. And if that hose ruptures, same thing. It fills the engine up with fuel and then fills the cylinders up, and to the point where the engine's not even going to run, and it's just going to be pushing all that fuel into the crankcase. And again, the engine's not running. So you're not really making oil because your engine's not running. You're just dumping fuel into your crankcase, into your cylinders, into the intake. It's a massive leak and you're dumping fuel. So I wouldn't consider that to be making oil. So that is, one side of it. Now on the making oil side of it, this is going to be the larger discussion, because the making oil will vary depending on a lot of things. So for NTJ, you're talking about a 2011 and a 40 horsepower, and idling does play a fact in there. Temperature plays a fact into it, but we need to start from the beginning of where everybody's going to go, and that's the break-in process and what happens. So in order for an engine to make oil, basically what is happening is you're getting fuel pushed into the cylinder to make combustion. You got air, fuel, and then fire in order to make a combustion engine run. There are pistons inside the engine with piston rings. You've got, usually it's 2 rings for compression and then 1 oil seal. So on the piston, you're going to have 2 compression rings and an oil seal. So that keeps the oil in the crankcase out of the combustion chamber. Whenever you put fuel into the cylinder, if that fuel can make it past the rings into the crankcase over time, like a 100-hour period, you can make oil. So making sure that the piston rings are sealing the combustion chamber is what the issue generally is when we come to talking about making oil. Now, the break-in process is super important here because during the break-in process, some people say that you don't have to break in an engine because it's just a myth or whatever. But in the reality of everything, the way a combustion cylinder works is that the cylinder walls, so you got a piston, which, is a round thing. It's a piston. And then it runs inside of a cylinder, which is your cylinder walls. That piston goes up and down inside of that cylinder. In the beginning, or in general, you have to have peaks and valleys to the cylinder walls. So whenever they make the engine, it's honed out and you have high spots and low spots across the entire length of the cylinder. So from the top to the bottom, there are going to be these peaks and valleys. So it's not really like a straight up and down. It's kind of wavy almost. It's going to be the best way that I can explain that. And that is for oil. So the low spots in the cylinder wall are supposed to trap oil basically. And so as the ring goes across the cylinder wall, those low spots hold oil. And then that helps to disperse the oil along the cylinder walls, and then the high spots help to create and seal the combustion chamber. In the most simplest forms, that's the best way I can explain it. Because at the top of the cylinder, you're going to have more heat. At the bottom, you're going to have less heat. And every metal is affected by heat. So when it gets to a certain degree, the metal is going to expand. Now, thermal expansion, I'm not a scientist. I'm not a metal expert, and so different types of metal and different types of things. I'm not 100% on all the scientific breakdowns of all of the physical attributes of metal and thermal expansion, but I understand that a metal, when it gets hot, will expand because the particles and the atoms that make up the metal, they kind of get away from each other, which it makes it expand, which goes into our break-in process. In the beginning, a brand new engine has, these peaks and these valleys built into the cylinder walls. And then on top of that, you've got the lower unit bearings and the races and the crank bearings and the crankshaft itself with all the balances, the valves, the piston rings, the compression rings, and the cylinder walls. All of these things are brand new metal. So whenever we break it in, you're breaking in all these metals to mate to each other. Now, whenever the piston rings go up the cylinder wall, it's actually scraping across those high spots, and they're like wearing themselves in. I think it's more that the cylinder walls are getting worn down, like those peaks are getting worn down compared to you actually scraping or shaping the piston rings themselves. I might not be 100% correct on that, but I think that's more the process, is that when it's breaking in, you're scraping down those cylinder walls, which is mating the piston rings and the cylinder walls based on those peaks inside the cylinder walls. This is what makes the heat so important, because if you don't get the engine hot enough under a load, then that metal's not going to expand to where it should be, and it's not going to scrape down those peaks the way it should, and you're going to it's not going to break in properly, which is going to leave you with gaps between the cylinder walls and the piston rings. It's not going to be a good seal, which will add to the issue of being able to push fuel from the cylinder into the crankcase, which is where your oil is. That's the most simple way that I can explain that process. Also, a load plays a big part of this as well, because if you don't load the engine, then same thing. You're not getting the right pressure or compression put on those rings, where pressure and compression also with the heat will make the rings expand, or, I guess expand's the right word. So it's going to make the rings expand, and that's going to get it to seal properly. So at idle with no load, those rings aren't really expanding to where they should be because they're not hot enough and they don't have enough pressure on them. So if you take a brand new engine and you let it idle with no load on it, big problem. Like that is a big problem because you are, one, they're not getting hot enough. They're not expanding. They're not scraping down the peaks the way that they should. And now you are breaking it in to where those components aren't breaking in properly. And now the idle with no load creates a whole new issue of glazing. And what glazing is basically you are creating carbon and oil deposits that are filling in those valleys, and it's messing with the peaks as well. So that oil and carbon, that residue is going to fill in your cylinder walls, and that's going to create a glazing where it's not going to properly seal ever. That deposit is going to stick to the cylinder walls and the rings and just in general the whole cylinder with all the parts in there, the compression rings, the oil wiper seals, the on your valve seats, the seats of the valves. So all those components are going to build up this glazing, and that's going to create, it's not going to seal. So now you're going to be, again, pushing that oil or that fuel into the crankcase because nothing's sealed properly. And once that deposit is made on there, it's very hard to get it off because you have to get it really, really hot in order to get it off, which is part of the problem. So that's kind of the break-in and the issue there. The low idle issue that you're talking about is that the engine's not getting hot enough. That's basically what it is. So if you have glazing on your cylinder walls and you're not ever running the engine to wide open throttle, which means that the temperature of everything is not ever getting up to the correct temperature, then that's why he was looking at the thermostat, then it's always going to be making oil because it's never getting hot enough to burn off that glazing, to burn off the carbon, or to get a complete combustion of the fuel that is being put into the engine based on the different engines. So now that we understand all of that, we can go ahead and talk about the other issues, being that in order to get rid of glazing, you have to burn it off. And the best way to do that, or the best way to stop this issue, is to basically try and get the engine really hot. And depending on the water that you run in or other factors like the kind of propeller that you have, which is going to play more into the show. We'll talk about the SHO after this. So that's why it's so important to break in the engine in order to complete that process and get everything going, and to not idle during the break-in process. But also, if you idle around too much and you already have a glazing problem and you have a break-in problem, which the break-in problem and the glazing problem, that can generally be fixed by getting the engine up to temperature. So you can try and break the engine in, even if you got 200 hours on the engine. Your issue is more going to be the glazing and the piston rings not being properly broken in. And what you can do is you can try and break them in. Break-in process is pretty simple and pretty standard across most engine manufacturers, and it is basically do not idle the engine, and you get it up to temperature. So for the first hour, you want to run your engine at varied RPMs. Go up to like, say 4,500, 5,500, not wide open throttle, but 5,500, 4,500, somewhere in there RPM, in order to get the temperature of the engine up. Once the temperature is up, 10 minutes is probably fine. You're going to now vary the RPMs. Go down to 1,500, go up to 2,500, go up to 4,500, and just every 10, 15 minutes or so, vary those RPMs, because you're going to be changing the load that's on the engine. So at 1,500 RPM, you're going to be plowing the boat, which is going to be, you're not on plane, you're plowing through the water, which is going to load up the engine. And because you got the engine hot, that load is going to help you to burn off any glazing or any problem and heat up your rings. Then bringing it up to 4,500, you're bringing that heat up. So you're bringing the heat up and you're cooling it off. You're bringing the heat up, you're cooling it off. You're loading and unloading the engine based on being on plane, RPM, and temperature. So just continue varying those RPMs between 1,500, 1,000, 4,500, 5,000, 5,500, whatever it may be for the first hour. And then after you do that for an hour, changing every 10, 15 minutes, again, changing the temperature, changing the loading of the engine. The next one, you're going to continue that process, but you want to throw in a wide open throttle, which is, going wide open throttle, trimming it up, getting as high RPM as you can, which is going to give you as much heat as possible. And it's going to change the load on the engine. So when we talk about load, you're talking about an engine basically has a horsepower torque curve. And without getting too technical, the more RPM you have, the more horsepower you're going to make. And at certain RPM, you're going to make more torque. And, as you get all the way up, at the end, it starts to curve off. So the most horsepower you make isn't, it is. The more RPM you get, the higher the horsepower goes. But there is a torque curve based on, you need air and fuel to make an engine run. The more air you get, the more fuel you get, the more horsepower you get, the more power you get, the more combustion you get. And the mapping of that is based on the timing. So as you go up in RPM, there is a curve based on the engine's mapping and how much fuel and how much air it's getting inside the cylinder. That is going to change. And as you go up in RPM, the engine itself maps out the timing based on when it fires the spark plug, how much fuel it lets in the engine, and how much air, being how long the injector stays open, which is an injector width. So if the injector stays open for a millisecond, 2 milliseconds, 3 milliseconds, it's adding more fuel. So as you go up in RPM, that torque curve is going to change because you're adding more fuel, you're adding more air, and your RPM is changing. So at wide open throttle, you're getting hot and you're adding as much fuel and as much air as possible. There is a difference in the torque curve, and it does kind of slope off at the top, but that's besides the point. Main thing is to understand that the heat and the amount of fuel and the amount of air is going to change based on the RPM, and then the load that's on the engine is also going to change based on your propeller. That wide open throttle is going to give you that heat to help expand those rings to scrape the walls of the cylinders, and the heat is also going to help to burn off that carbon and that oil deposits, which is the glazing on your cylinder walls. So if you use a product like Ring Free or Seafoam or any other kind of decarboning fuel additive, that is going to help you to burn off any glazing if you have a glazing issue with your engine in making oil, or even burning oil to a point, which we'll get to burning oil next. But the main thing that you need to understand is that there's other products out there. So if you have a big problem, so the 3.3, let's go with Yamaha. The Yamaha engine, being the 3.3 liter, was when they first came out with the plasma infused cylinder walls. Plasma infused, these walls on the cylinder are super, super hard. It was very hard to break in the engines, and most people say that break-in's a miss, so no one was breaking in the engines properly. A ton of them have a problem with making oil, where it's not really making oil, and the rings, after so much time, you're never going to fix it. They're always going to make oil. But at the same time, those hard cylinder walls were hard to break in, and in order to fix the problem, they made a product called YIC, which is Yamaha Internal Engine Cleaner. It's not sold to the public, but it's basically a very, very, very concentrated solution of ring-free or a decarbonization component. There's also Johnson Everett Engine Tuner and Power Tune. So these are chemicals that can help to break off that carbon that's in the engine. And so what you can do as a trial, but this is something that, every engine manufacturer, and myself included, is going to tell you that, you doing things like this to try and fix your making oil problem, no one's liable. This is on you, how you do it and what you do. If you damage something, that's on you. That's not on anybody else, and no one's going to tell you any different. That's why they don't sell YIC to the public, because if you do things improperly, you can damage your stuff and no one's going to be held liable for it but you, because you did it. So what they do with yick is there's a specific solution that you can do. In an external fuel tank, you can mix up your fuel with the yick. You can only buy ring-free, Seafoam, Power Tune, Engine Tuner, stuff like that. And you can mix up a very, very heavy solution of fuel and the decarbonization product, and then put that into the engine and then go run it as if you're breaking in the engine. The heat and that cleaner together it's going to clean that carbon and that glazing off of the cylinder walls, which is going to help the rings to also seat properly, depending on whether you've got a glazing issue or you've got a ring problem, because you could have a ring problem also where your rings are just messed up and, no amount of detuner or anything like that's ever going to fix the problem. But with that being said, you can mix up the solution and run it and try and break it in, but you have to be careful because you are changing the amount of fuel. So that cleaner is very hard. So if you run wide open throttle and you're running it on a fuel mixture that is mixed with a very heavy decarbon, you can clean the oil off of it. So there's another problem that we can go ahead and talk about now. I'm pretty sure it's called burnishing. And burnishing is where the fuel is washing the oil off of the cylinder walls, which can damage your cylinder walls. You can scratch them. So if you run too heavy of a solution, that cleaner and that fuel is washing the oil off of the cylinder walls, you can actually damage it because you're going to get metal on metal contact, which is going to scratch the cylinder walls. It's going to mess up the rings, and it could be a problem. So that's why it's a do at your own risk type of thing, outside of having a dealership with a certified tech that gets the right ratios, which when you're using ring free or Seafoam or something like that, you can't, the way you measure those ratios compared to your fuel is going to be dependent on what you're trying to do. So if you mix it up too heavy, that's what's going to happen. You're going to wash the oil away, and burnishing is another problem that probably goes into the show. So let's go ahead and talk about the show. Basic info edit says, what about the Yamaha 200 show, which is an SHO. Many owners can't get them to stop making oil. And the 200 show is an SHO, super high output engine. It's basically a performance engine. And that means that the mapping of the engine for that aggressive hole shot and the tuning in the engine, going back to the mapping of the engine, more air, more fuel gives you more power based on the torque curve and how the engine is set up to perform. So an SHO is basically a performance engine. If you take an SHO and you go out and baby it and run it, only at idle, only at trolling, and you're never running wide open throttle, you're never getting the engine hot, you don't have it propped aggressively enough, whether that be over propping can be a problem, under propping could be a problem as well. So based on the propping and the loading of the engine, you might be getting too much fuel in the engine. So you're going to be, it's not really burnishing, because burnishing is, past the point of, cleaning the cylinder walls off and getting metal on metal contact. That's a whole different problem. You're actually creating a bigger problem where you have a very heavy fuel mixture going into the cylinder. And if you're only idling all the time, that higher fuel to air ratio being put into the cylinder, you're going to be pushing the fuel. The piston rings are not getting hot enough. They're not expanding, and they're not sealing the cylinder walls properly because you're never getting the engine hot enough. So it's always going to be able to push fuel past the rings into the crankcase. So no matter what you do with a performance engine like an SHO, if you only idle the engine, you're going to make oil. I mean, that's just what it's going to be, because you're never getting it hot enough. You're never able to burn that fuel off, and you are eventually going to be creating a glazing of the cylinder walls, and you're going to be creating carbon, which as you run the engine longer and longer and longer, the problem is going to be progressively getting worse. So a lot of SHO people, depending on how you run the engine, you can fix the problem by changing the propeller. And if you change the propeller and run it a little more aggressively, your problem is going to go away. It's not really a glazing break-in problem. It's just that you're babying a performance engine and you're idling around, never getting it hot, never, burning off any of the carbon or the fuel or any of this stuff. That's going to be the SHO problem. But back to the 3.3 liter, the cylinder walls being plasma infused, most of them, they didn't get any of the rings to seat properly because they weren't broke in properly, and they're babied. You're trolling a lot, you're idling a lot, and you're never getting the engine hot. So you're just pushing fuel past that. These are all naturally aspirated problems for a naturally aspirated engine, which naturally aspirated means that it's not supercharged, not turbocharged, it's just getting straight air. On a supercharged engine, creates boost. It's a forced induction. You are creating air pressure. So you're pressurizing the air, you're creating boost, and you are pushing more air into the cylinder, and more air means more fuel. So you can create horsepower because you're getting more air, more fuel into the cylinder. But problem with that, and why like Verados and other engines will burn oil, is because you are pressurizing that air, which, depending on how you run the engine, if you idle a lot, if you troll a lot, and you don't ever get it hot enough, the rings aren't going to be seating properly, and that pressure of the forced air into the cylinder is going to get blow by, which is going to be you're pushing pressure past the rings into the crankcase, which is pressurizing the crankcase, which is going to be based on the strokes. You have a different stroke, 4-stroke, 2-stroke, 4-stroke theory, where you have different strokes. You have a power stroke, you have a compression stroke, you have an exhaust stroke, you have an intake stroke. So on a compression stroke, in a power stroke, you're going to be burning all that stuff off. But on exhaust and on intake, you're not having that same type of compression being made, and your cylinder's just going up and down. The pressure of the crankcase is going to be able to push oil into the cylinder, which you're going to start burning oil. And that's why you're going to burn oil, and the cylinder's going to mess up. So a supercharged engine, I would kind of say, based on the way a boat is and the load that the engine goes under, they're going to burn oil. That's just what it is. It's going to burn oil. And then also, not to mention that most of them are vented. So the crankcase is going to have a vent that is going to vent up to the intake, and if you have too much blow by, it's going to pressurize it. You're going to actually push oil into the intake, so you're going to be burning oil because you're pushing oil into the intake. So that's a whole nother problem there. Generally, it's not enough for you to notice unless you don't do your oil changes properly. So if you do, say, 150 or 200 hours without changing the oil, you're gonna run low on oil. Whereas if you do your oil changes correctly in 100 hours, you generally don't burn enough for it to be you're not gonna burn 2-3 quarts of oil in 100 hours. But as the engine gets older and you have carbon buildup and other things, that problem, you're gonna burn more oil over time. Again, based on how you run the engine, whether you have a lot of trolling and a lot of load on the engine with low RPMs, it's going to create more blow by, and you're going to burn more oil. Also, when you shut the engine off, this goes for any engine too. If you notice that you're smoking a lot at startup, when you shut the engine off, if you have it trimmed all the way down, your cylinder walls, your cylinder is going to be sticking like this. And if you have it trimmed down, the cylinder walls are going to be pointed down. So when you turn the engine off, there is oil on the cylinder walls, and as it sits, that oil is going to drain down, and it's going to drain past the rings into the cylinder. So when you start the engine up, it's going to burn that oil. You're going to have a puff of smoke when you start the engine, and you're going to eventually be burning oil that way as well. Easy to fix that. When you shut the engine off, just trim it up a little bit. So that way your cylinders, opposed to sticking down, they're sticking up. All the oil will run down and then run back into the engine. And usually that fixes the smoking at startup kind of thing. But Dirty South, moving on to a different topic of burning oil. He says, what about burning oil? I am having a time with a 2016 Suzuki 300 burning oil. I just seafoamed and ring freed it It literally runs fine, just burns about 1.5 to 2 quarts in a 140-mile round trip. I was told it's because the motor has been run idle for way too long or lower RPMs for way too long. This motor is literally 5 degrees colder than my other motor. I can never get it up higher than the other one. I was told to dust the motor by using Barkeeper's Friend and it would reset the rings. I don't really subscribe to that. I mean, I've tried a bunch of different things and I'll try anything, but I don't know if I would try that. I mean, if you think about what you're doing there, Barkeeper's Friend, I mean, I've heard of it. What was that stuff called? The Bon-Ami or Bon something or other. And then people would use Ajax, Barkeeper's Friend. You're using an abrasive cleaner. And I guess the theory of what you're doing is that, I mean, I look at it like this. You're taking an abrasive cleaner. If you put that into the air or the carburetor or whatever, you are taking that cleaner, which is like sand, and you're taking that sand, throwing it into the intake, and now all that cleaner, though it dissolves, it's going through your injectors, it's going through your fuel pump, it's going into your cylinders, and now that abrasive material is now on the rings, scraping across the cylinder walls. I don't think it's a good idea. Will it work? Possibly. I would rather go with something like, Seafoam or ring free. One thing that you said that you tried to ring free it, most likely you might have another problem. You really need to do a compression test and a leak down test. If you do a leak down test, you might find that, based on where the leak is, are you talking about having a ring problem? Is it a valve problem? What exactly is the problem? You need to figure that out first, and then that is going to say, whether you take one direction or the next. On that, if it's running cold, the heat's going to be a major problem. I mean, you need to get the thing hot, but then back to the other thing about running too hot of a mix of cleaner into the engine, you can, create a problem. I don't think I'd do the Barkeeper's Friend thing just because, again, it's like throwing sand into the intake. I mean, at what machine shop is going to be like, or engine manufacturer in general, is going to make him engine with tight tolerances and then put sand in there. I mean, I get the idea. Just not something that I would really try. I would try and do something else because you might have a burnishing problem over a glazing or a carbon buildup problem. 1.5 to 2 quarts of oil is a lot of oil. You might have a legitimate oil leak. Like you might have a bigger problem than just your rings not being seated properly or having a glazing problem. So I don't know. You need to do a leak down and do a compression test and see exactly where the leak is, but you might have an oil leak, not really a burning oil problem. And we're going to go off from the oil now and go on to a whole nother topic of oil walk. Does the block half gel seal fail after 48 years? Were they designed to run with 10% ethanol in many cases? Half gel cell seals are basically whenever you take an engine and the blocks are put together, they use a gel seal, which is like, you put a gel on there. When you put the block together, it seals it. Ethanol does have some, effects to it that are harsher on rubber, on diaphragms, on seals, on, different, what would be a way, solutions like, epoxy and other things like that, different types of adhesives, I guess you would say. So ethanol being an alcohol-based product, it does have some adverse effects. So no, I don't think that the seals were made to have that issue. But I mean, 48 years, the seal, it's probably going to break down. I mean, honestly, I would say yeah. And an engine that's 50 years old, it might need to be torn down and rebuilt anyway. I mean, two strokes, you would rebuild two strokes quite frequently. After you run 1,500, 2,000 hours on a two-stroke, a lot of them would need some sort of a rebuild because they just wear down. I don't know if they were designed. I don't think anything was really designed to do 10% ethanol in many cases, and there's a lot of places where you can't get anything but ethanol. So I would say that they probably weren't designed. Does the block half gel seal fail after 48 years? Probably. James Schultz, if you are buying a new 200 to 250 horsepower Suzuki, would you get mechanical shifting or new fly-by-wire? I'm going fly-by-wire. I'm going digital throttle, digital shift, 100% over mechanical, especially on 200, 250. The larger the horsepower, I mean, I don't even think that you can get a mechanical 300, 350, even some of the 250s. I think Suzuki's you can, but like I don't think you can get a mechanical 300 Yamaha, or I mean, I think you can get a mechanical 300 Mercury, though they're probably pretty rare and it's going to be a special order. I wouldn't do that. I think the DTS, the systems now, Suzuki's, Mercury's, Yamahas, all the fly-by-wire stuff, that digital throttle shift, that command link stuff, fly-by-wire, whatever you want to call it, it's outstanding. I mean, I would rather go with that no matter what. And honestly, like on Mercury, all their engines are digital throttle and digital shift. They aren't mechanical anymore. Not 200, 250. I mean, the 150 and lower, that low stuff, yeah, those are all still mechanical. But like on a V6, a V8, they have what are called demand sensors on them. They still have digital throttle. They still have digital shifting actuators. And you have demand sensors on the engine that a control cable goes to. When you shift it or throttle it, that cable moves that sensor. That sensor tells the engine computer, the PCM, what to do with the shift actuator and the throttle valve. So the throttle and the shifting is digitally controlled on the engine already. So even if you get a mechanical control, it's going to save you on the money as far as the rigging goes, but the engine itself is still digitally controlled as far as the, throttling and the shift aspect of the engine. So I'm going digital throttle, digital shift. I'm going fly-by-wire. The ease of operation and the smoothness it's just way better. I mean, once you drive fly-by-wire and then drive mechanical, it's just so much nicer because you don't have to slam into gear anymore. I mean, like, anybody that runs mechanical cables, you have to put it into gear. And there's a lot of people that aren't really used to that. They kind of like baby the shifter into the gear, which is really bad. You burn up your clutch dog and, you hear that grinding sound on the clutch dog. So, yeah, I'm going digital. Don't baby it. Pop it into gear if you're mechanical. Sam says, have we been draining oil in order to pull the lower unit ever for any brand? No. Yeah, Mercury was the only one that came out with that, and I don't know why they did that. Even the Verado, it's in the design, and no, that's the only engine that you ever have to drain the oil in order to drop the lower unit. One model, one brand, that's it. So, yeah, pretty funny. Gonzalo Miranda says, what's your opinion on Dusky boats? I'm looking to buy a Dusky 227. I'm a huge fan of Duskies. Everybody, I mean, if you know me and you watch the content enough, I love a Dusky. I think they're one of the most underrated boat brands out there as far as the quality of the ride, the price, and the usability of the boat. They are not like decked out with all the frills and everything. It's a really like stripped down boat. They're not like, super finished with a bunch of stuff on them. You can get them kind of really basic and set down. So if you want to go fishing and you want to go offshore fishing, Dusky is, I love a Dusky. I do. I love a Dusky. So if you're looking at getting one, pull the trigger because you're going to be super happy with it. And then Jerry wants to know, have you an opinion on Wahoos? I like Wahoos. I think Wahoos are a great boat. Their flats boats are really nice. I don't know much about some of their bigger stuff, but I know the flats boats, the ones that I've been on, I was impressed with. I think it's good. I think the price is good. And I think the build quality was good in that they lasted. They had a good ride. The quality was there. And yeah, I think Wahoos are good. I think they're desirable too. You can get a lot of people that want to get a Wahoo boat. So they do kind of tend to hold their value. Beer Bourbon Bates says, anyone have any pointers on where to get good used parts other than eBay? I just picked up a Project Motor 400 Verado for refurb. This is the perfect video for setting up a test stand rig. Thank you. Thank you, Beer Bourbon Baits. And as far as used parts, eBay's kind of the best way, but then there's a lot of other ones out there. Great Lakes Skipper is one. Marine Connection is another one. I think there's a place called Jerry's in Tampa. Maybe it's Fort Myers area. Or no, there's Don's. There's a place called Don's Mobile or Don's Marine or something like that. And that is in either Tampa or Fort Myers. I can't remember which. Fake name says, speaking of tuning mods, I just got some Chris Carson Marine Services performance reed valves for my parts spare Yamaha 25 two-stroke. They had different RPM specs for the reed valves. Example, some are drag reeds rated for 10,000 RPM wide open throttle. Some are sport reeds rated for 6,500 RPM wide open throttle. I picked out the sport reeds. I'm now wondering if 91 octane is still good to go with the max RPM raise, or if I should be running 93 octane, highest octane I can get at the pump. To be honest, I probably need to change prop to even get to 6,000 RPM, never mind the rated 6,500 RPM. So mainly just hoping it starts easier or runs a little bit better. Chris Carson, he has a shop down in Key Largo. For those of you that don't know, he does a lot of rebuilds, engine rebuilds, stuff like that. They make different reeds like he's talking about. He got for his 25. I don't know if changing the octane is really going to make a difference in your performance or your fuel economy or anything, only because when you're talking about that, especially on like a 25, because it's a smaller engine. So on the 25, like this is a two-stroke. So the timing of the engine is what you're talking about. You can add, whenever you change a mod, like you add these reeds, it's going to let more air into the engine. So if you let more air into the engine, you need to let more fuel into the engine in order to take, to maximize or to take advantage of that air that you put in there. And then when you get more air and you get more fuel, in order to take advantage of both of those, you now need to change the timing of when your spark is in order to take advantage of that. And then also that is going to be based on that RPM, that torque curve, or that horsepower torque curve that we were talking about earlier of, at certain RPMs under certain loads, the engine is going to make a specific amount of horsepower, which is going to require a specific timing and a specific amount of fuel and air ratio. So I don't know if I don't really know that much about tuning. I just understand that much of it. Changing the octane, I don't think you're going to see any difference in changing the octane based on the other aspects of it. You might get easier starts because you're getting more air in there, but on the 25 two-stroke, if you haven't messed with your carburetors in order to get more fuel into the engine to take advantage of that air, and then also I'm not exactly sure how to change the timing of that in order to take advantage of the extra air and the extra fuel. If that is, I'm guessing that's what the drag rates, I'm guessing they allow more air in at 10,000 RPM wide open throttle in order for you to get that much RPM. And then that RPM is going to increase your horsepower. So if you've got a 25 horsepower and you spin that thing up to 10,000 RPM, you are probably making more than 25 horsepower. So I don't know. I don't think you really need to go to 93 octane. I think the 91 is going to be fine. But also the 91 octane, at the pump, are you getting, is that 91 ethanol free? Because that's also going to play a factor into it too. I'm pretty sure the 93 octane that you can get at the pump is going to be 10% ethanol. So you might have some adverse effects there, but I'd run the 91 and hopefully that 91's ethanol free, and that's what I would do. NTJ also wants to know, I'd love to get on a live video to ask a question. Is there a schedule for the live video? Yeah, if you become a member to the main channel, so if you go to Born Again Boating on YouTube, and underneath the subscribe button, there is a join button. If you become a channel member or if you join the Boaters program at bornagainboating.com, that is kind of how we pay for everything, and that's kind of what sponsors all this and allows us to make all this free content. But we do a weekly live Thursdays, 4:45 p.m., and you can ask questions there for anybody that didn't know about that schedule. 4:40 p.m. P. Mora, great video as always. Thank you. Do you have any suggestions for spark plug sockets? My sockets will not fit on my 4-stroke Suzuki. I use Snap-on spark plug sockets. Usually they're either a 5/8 or a 13/16 or a 14 millimeter. And I'm not sure exactly which one you've got. It needs to be a deep socket, and I buy specific spark plug sockets. So I'm not sure exactly what your spark plug is, whether it's a 5/8 or a 13/16 on a 4-stroke Suzuki. Lots of different models. So most likely it's going to be a 5/8 or a 14 millimeter. And depending on which one you need, I would just buy a spark plug socket, or you can go to Harbor Freight, depending on what you're, or if you're doing it very often, I would buy a quality one. If not, if you're only doing it every other, once, twice a year, go to Harbor Freight and just buy a spark plug socket set. Usually they come with like 3 or 4 or whatever, and they'll have like magnets or a rubber piece in there. So when you put the socket on the spark plug, that rubber, that magnet will hook onto the plug. So when you pull it out, it keeps the plug in the socket. So not sure which one you have. Drone View HD says thoughts on Scout 240. I'm a big fan of Scout, so I like all their models. I'm not, 100% on the 240. I think that's the new bay boat that they have. I thought it was pretty dope. The one that I saw at the show, I really liked it. So I'm a fan of Scout though. So they're super expensive, but they deck them out and they're really nice. So, and they ride really good too. So I'm a fan of the Scout 240. Paul says, does this apply to trolling motors mounted to the outdrive or outboard? Talking about putting on a trolling motor on an older boat. Older boats, kind of the bow, the shape of it, and whether or not the bow can take the force of the trolling motor. Not really. I mean, the trolling motor itself on the outdrive or the outboard, if those of you have never seen them, I don't know if you can still buy them. I mean, I haven't seen one in a long time, but they do make trolling motors. I'm sure they still make them. I haven't seen one in a long time, but they make them to where they will bolt onto the anti-ventilation plate of your outboard. And it's basically just like a little jet pack that sits on top of the anti-ventilation plate. And it's a trolling motor. So it's not really going to affect the ride or the performance of the boat. So no, I don't think it does apply. I think put the trolling motor on there, depending on what you do. Most of those are more for like river and applications like that. Like if you get into a stream and you want to use that trolling motor opposed to your regular engine, you can just kind of turn that thing on. Also, some of them will go on your trim tabs, and they'll just kind of like hold you into, in one spot to kind of hold you in a spot. Like if you're in a current, like an inlet, a stream, a river, the mouth of something, you can just kind of like set that there, and it kind of keeps you straight, or well, not straight, but you have to, move the engine in order to control it. But, it'll keep you pointed into a direction to sit somewhere in a current. But other than that, I don't think they apply as far as changing the ride of it.